Hey, I want to bring another tutorial to y'all. This one's going to be just about how we deal with state and changes of state through time in web applications. So to kick off, I want to give some background. So if you spend any time dealing with react.js, you've probably heard of something called Redux before. And before that, Facebook had a Flux library, and I learned that and did similar things. They behave in similar ways. And actually, before even I learned Redux, I learned from a language called Elm, and this one was a fun language to write in. It's very Haskell-like. I kind of got to scratch my functional programming itch, but it introduced me to this idea of the Elm architecture, which I won't totally unpack, but the key concept here was that it was really initially built around this idea of web applications are a stream of events and the result of the state being transformed by each event as that stream gets processed by the application. So another way to think about that is Redux exists because we needed a predictable state container for JavaScript applications. So the idea there is, when I started programming and maybe in like earlier days, earlier days for me anyway. I started with like jQuery and then eventually Backbone.js came out. And the idea there was we originally were looking at, we had code that needed to respond to a user doing something like clicking a button or hitting a drop down, logging in or logging out. All of those things are state. Even what page we're on currently, that could be state. And that state can change through time. So you'd have your code that deals with state, possibly very close to the state or to the UI that changes it. Maybe your state changing code is all in one place, but most of the time it was just scattered everywhere. And you had to kind of remember, well, okay, where does the code live that changes who's logged in, or how many different places are allowed to touch state related to the current form or something like that. So your code could be spread out all over the place, and that's what the centralization piece here is talking about. Is it's much easier to think about and to test and to reason about your application when all the functions and the functionality related to state changes in one place. Meanwhile, if you've got predictable functions that only behave on their input, we call that pure functions. So a function only operates on what's given to it, as opposed to having access to, other variables outside about the argument or global state or, functions that might return a value but might change something somewhere else. So running the same function 2 or 3 times in a row might have different outcomes just based on how they make changes, and we call those side effects. So these programs are much harder to think about and harder to test when you have all of this state leaking around. So that's why things like Redux came to be. And what I want to be able to do is give you a way to kind of abstract this problem so that instead of learning Redux, you're really kind of learning the problem that is state management through time and web apps. And so to do it, the reason I'm calling it Streamux is that we're making it based on this library here called Highland.js. And what it does is it's an API and a set of tools for dealing with streams in Node.js and in the browser. Now there are already a ton of stream-like functionality. Streams can exist in the Node standard library. You can think of like event handlers. So like the on method on a lot of event emitters, like that's a stream of events. So Highland does support a lot of things that are stream-like, and it can work on arrays where that's a stream of values where all of them show up at the same time, or files, which is read byte by byte. Same thing with web requests, promises. So Highland can kind of give you the same interface over all of those things. So we're going to use this concept to make a framework for dealing with state in a web application and having it react and update to events streaming through our app, where an event could be any interaction done by a user or on behalf of a user. So that's what we'll look at. So to get started, we'll dive into code, and all of this will just be done basically here, and we'll build it up as we go. My approach is typically to start solving a problem, run into a problem on purpose, just to kind of help you understand motivations and why things were even invented to begin with. And then we fix that problem as we go. So we'll start making two little files here, and I'll open up my editor. So I've got already something set up. I've got a div with an ID of app, and we'll render into that. That's where our application will live. And then I've got a bunch of libraries that we'll need. So we're going to work with React. And if you're not familiar with React, it's just a toolkit for making UIs and rendering DOM elements to a web page. And it's nice because it comes with this syntax called JSS, which makes it look like HTML inside of our JavaScript. But the browser doesn't know how to read JSX natively. So rather than setting up Babel and Webpack and configuring all these things, we have Babel standalone. And you'll see here that I'm giving this to type text Babel. So if our application contains JSX in it, this Babel standalone program is going to know to just transform things for us. And then we have our library code, which will mostly start out as empty and then highland when we get to it. So let's crack in. So the first thing that we want to do is we want to just render something to the page to get started. So the React DOM library gives us a render method, and it's supposed to go into expect, a React element and a target, an HTML and an element to render into. So target will just be get element by ID, and we had that app node that we put earlier. So let's make a component in React. And it's going to be pretty simple. It will just return a basic hello world. So great. And then we'll render that in to the app like this. So now if I come over to this, I want to serve all of this from localhost, and that won't work yet because rather than serving it directly from the file, I need a little web server, and I want to be able to serve these files. So if most computers will have Python or Python 3 installed, and those come with a built-in little simple file directory server listening on port 8000. So we'll pop that open. And so now it's got hello world. Hopefully it's easy enough to see. And so that's just coming from React. In Babel, it's telling us that those are, here's the in-browser Babel transformer. So all that's working. Let's clear that out. Let's get started on doing something more interesting. So a really good common demonstration program is a counter when we're dealing with programs like this. So let's deal with a counter that'll take in some values. A counter is just going to basically right now have the value that it's counting, or the current value of the number that we're tracking. So let's have a div and a span and then render out the current value. So here we're going to do this, and we'll put value, and then we'll take that from the props. Okay, so let's put an equal sign in there. So I haven't actually used the counter yet, so let's replace our hello world with a counter. We'll pass in a number, and I've got 42. Great. So I want to do something a little bit more interesting. I want to make that number change. So right now this is just a number literal that we're passing through, but we want to start introducing some state. So we'll keep that counter value in state. All right, so let's put counter, and we'll say counter has a value, and we'll start it at 0. So here we want to take that out. And from here, let's see. So we've got that. The next thing that we want to do is be able to respond to the user clicking on some buttons to change it. So what we'll do here is we'll make 2 buttons. One will be for our minus sign, one will be for our plus sign. And what we want to be able to say is we want these to do things, because right now, if I render that out, I can click a button, but it doesn't do anything. So React elements give us, event handlers, ways to hook into those. So here, I want to be able to say on increment, sorry, this is decrement, and this will be on increment. And we'll expect that those have to be given to us from the perspective of the counter on increment, on decrement. And for sanity's sake, I'll just sort those. Cool. So how do we specify, right? So our caller gets to say what it wants it to do. This is the application logic. So on decrement, we're going to have a function that basically says state.counter. Sorry, let's make this a function. This is an inline function in JavaScript. Equals state.counter.value -1. And incrementing is basically going to be the opposite. Cool. So let's run that. And this kind of seems like nothing's happening. But in fact, I can show you that something is happening. So let's do this. And we'll print out the current value of our state. This is like our, you can think of it as an app global. So if I hit the minus sign, I print out twice that counter starts as, well, because I clicked them too fast. Let's do this again. Now they've got -3. All right, so the state is changing. We are mutating it, but our UI is not responding to it. It's not reacting to those state changes. We need some kind of way to tell the application, hey, I've got new state, do something, do a thing. So we can do that. We'll introduce, a little method or function that we don't have yet called render. So we'll just come down here. We can just basically wrap this and say we've got a render method. Functino. All right, so that's going to help let us trigger when we've got a new time to update. All right, so we actually need to run it for the first time like this. Okay, so now we can update and we can update our UI accordingly, right? So this pattern isn't super great, maybe for a tiny problem, but like let's say we want more than one counter on the screen. Put a comma over here. And so that we want to basically update all of the counters to say counter 1. We'll do the same thing down here. Okay, and then this needs to be counter 1. So now we want to have 2 of these counters. We want the second counter to be tracking counter 2. Cool. So now if I upload this, I update this, I've got 2 and they are updating independently. Now this can turn into a mess real fast, right? We got a couple of problems that we want to deal with. The first is that there's no centralized place to manage all of our update code. You've got it scattered here, here. It's just all over the place. And you can imagine if these spread across different files, it'd be a huge mess. Another problem is we don't have a single place to synchronize the UI with the state when it changes. Other problems, we're mutating the state directly. And another problem is that we've got direct visibility and access to the state, which is to say this code down here is dependent on having scope and visibility to the rest of the state variable to update it. And the reason that that's problematic is that like I can't move this to another file then without losing visibility to, being able to update things from there. So let's start solving some of these problems. Instead, one of the things I can do is maybe introduce a function that notifies the system it's time to update. Just by convention's sake, most Redux users will know this as dispatch. Same thing with Flux. So this one will take an event. We'll call it action in this case. And its job is basically just to kind of hook into and cause to hook into that action, cause a state update to happen, and re-render the app. So we'll do that manually right now. So we'll say that there's some new state, and we'll call some function called update, and we'll give it the current state and the action, and update's job is to give us the new state. And then we want to render, and we want to render this new state. So let's update render to receive the state. So I'm going to come down here and receive state, and we'll pass it to our application this way. We got to do this down here for the first call. So now I got to update my app. It's taking data now. So rather than having direct visibility to the state variable, we're receiving it as an argument. And none of this has to change because this was all referencing state before. Now we're just receiving it from our props, right? So we called a function that doesn't exist yet, so let's write that. So the idea here with the update is that we take our initial state and an action, and that action is just data. It's just going to be what lets us know this is the kind of state change I want you to make right now. So in our case, in our design, we'll say that action has a type property that we can switch on. So we'll say if it's counter 1 increment, what I want to be able to do is take the current counter state, and then I want to return a new version of the total state. So that's what this ellipsis does. This is called the object spread operator. So it's basically saying I want to keep everything that's in state. I just want to update the counter 1 property. And I want counter 1 to have a new value, which is counter 1 dot value plus 1. All right, so we can do the same thing for decrementing, like this. And then we're going to do minus sign. Now the nice thing is that the behavior is pretty similar for the second counter. So let's just kind of change the names here. Good. So now I've got 4 actions that basically describe all the changes that can happen in the app. If I get an action that I don't recognize, I want to let the developer know about it. So I'll put out a warn. Actually, let's put an error. And we'll say unrecognized action. It doesn't really matter whether it's an error or warning. But what we will do is instead of crashing the program or whatever, we'll just return the original state that we got unchanged. Okay, so now we've got our centralized place for updates. We have some way to hook into that. So now what we want to do is wire our app into that. So what we can do here is just pass dispatch through. Let's go to our app function. So now instead of updating the state right here in line and putting all of our business logic all scattered out throughout the code, instead what we can do is we'll just dispatch a new event, which was what, counter 1 update. And that's it. It's just data that declares this is the kind of action that we're updating right now. And I can delete this. Actually, this was supposed to be not update, but decrement. That's the kind of update that it is. And then in this case, decrement just becomes increment in the action name. We'll keep our value. And so now this basically becomes the same, except we're doing it for counter 2. I didn't actually submit that. Counter 1, counter 2. Good. Okay. So that's wired in. We're hooking up into the controlling code for us via dispatch. Now this is really just about sending signals to the application that it's time to update. So let's just hope that we got all that right. That updates, but they don't really update independently. Well, the reason for that is in my dispatch function, we're still dealing with this original state variable that's defined right here. We've defined it as a constant, meaning that we can't reassign it. And we get this new state, and we're rendering the new state, but the original state hasn't changed. Well, we can cheat a little bit, and let's just say that state, we're just going to replace the variable every time with this new state. So there what we have is the ability to like independently update that, but the whole global state application's been replaced so that we can remember what it was last time and update it from there. So again, this is cheating, right? We have mutating, that's still a problem, and then visibility and access to the state, well, that's been handled a little bit by passing everything through props. So now's the time where we can introduce some a framework to help us separate things out and to kind of be responsible for some more of these updates and get rid of our mutation. So we're first, this is going to be our first example of splitting code across another file. So we'll introduce a function called Streamux. And Streamux is going to drive all of this for us. So Streamux will want to take whatever our original state was. We want to take some kind of function that knows how to update our state based on actions. And then we also want to take basically this render method, which is like how to kick things off and notify that, we have new state, so please re-render the app. So what we'll do is we'll take the same dispatch function. It does a similar thing. And we'll call render down here to kick things off. But we need a way to give this dispatch function back to the application. So we'll do that here. We'll pass the original state that they gave us plus this dispatch thing to hook back into us. So here, we need an update down here, change surrounding that, dispatch. Cool, so what this lets us do now is we have, actually we don't need to call this at all anymore. That's being done for us. Render instead takes this variable dispatch. Okay, and so that's being passed through. So remember, this is being passed to us by the streaming library. I'm going to adjust this microphone here. It keeps falling down. Pardon me. Okay, let's keep going. So that's being passed into us from Streamux. So let's wire everything up. We're going to give it our state, our update, and this render. Most of this has already been written, just in the process of kind of improving this. We're working our way toward the pattern. All right, state, update, render, all that's being passed through. Now, in Redux, if we're going to be more idiomatic, we'll recognize some of this as actually connect, right? This thing's job has gotten a little bit bigger. It's less about rendering the app. It's more about connecting to our framework and hooking in so that it knows how to call us and we know how to call it, right? So we're going to recall this actually connect just to have a more clear intent of what it's trying to do. And that's called connect, and I'm going to make sure I remember to change it everywhere. Connect here, I got to give it dispatch and the state, and let's connect here. So we solved a good amount of our problems. Let's see if I got everything right. Good, so we're updating things independently, great. So we've solved just about all the other problems. We just moved things around, but we did not fix this mutation bit, which is happening right here. So this is where Highland can come in. We're going to give it our state, and we're going to ask it to deal with, updating things and responding to events for us. So if we come back over here to Highland, like I mentioned, it knows how to model streams and stream-like things. An array is a stream-like thing. The other thing that's neat about what it can do is it itself can be a stream source, right? So like here's an example with no source. We can pipe streams to it. We have our events. We're just going to call Highland with an empty constructor, and now it's a stream source and a stream destination. So to deal with it, we've got all of these functions that we can deal with on stream. So, we can transform things with like map, we can group things, we can filter things. There's a lot of helpful functions. So what we'll just do is we basically want to treat our app as the reduction. So like, let's read the documentation for reduce. It's going to boil a stream to a single value. It's going to take a starting value, which is the initial state of the reduction. Each step should be returned by this iterator function. The iterator takes the memo, which is the current state, like going through anywhere along all of the transformations, and then whatever the next value is. So this function will apply, some changes to that next value and produce a new memo or a new state. For an example, here I've got a list of numbers and a function that knows how to add 2. So A will be the running count and B will be the new number. So it starts at 0. And as we go through, all of these numbers added together add up to 10. So that's the idea of a reducer. Now the problem is this goes to a single value, but we want to see all the values in between. We don't just want to see the end result, right? Because again, as a user, it would just be like clicking everything and then not getting to see the UI update until the last click. So what we would like instead is something called scan, which is like reduce, but it emits each value along the way. So that's the one that we want. So scan takes the initial state, which is just state, that gets passed in, and then a way to update state as we go. And then if this is going to spit out each, like the status or the state of our data each time, we want to then just take that state and we'll call connect again to let the application know, hey, please re-render. We have a new state. Okay, so that's that. And I don't think we need this initial connect, do we? Yeah, let's leave it there, I suppose. I don't think we do. No, we definitely do. Okay, so that's the initial one, and then we've got dispatch. The other big thing that we need to change is we're not managing this ourselves anymore because we've got this function over here that's managing state changes for us. All this has to do now is write new events into the stream. And so this just becomes our action. So again, what's going on is dispatch, which is given to the UI, will call into this private Highland variable, and that's just going to be a stream of events. Each event runs through scan to update and produce new state. And so we're not mutating the UI ourselves anymore. We're just producing a stream of state changes. So we don't have to mutate the state anymore. So that is really simple in that it just gives us a few lines of code, and then we've got a way to just like deal with a stream of events. Most of our business logic all of our business logic still lives over here. This can work with pretty much any other program as long as it follows this state update connect, which if you spend much time looking at the Elm architecture, this is model, view, update, and view. And this is the same idea. This is a really good way to think about apps, and you can nest things down that way. But that's effectively what we've modeled. We just call it different things. So now I want to introduce you a new problem. Let's have something called a slow counter, which will behave just like a normal counter, except when we request to update it, it happens not right away, but it happens later. So let's see, like model how that would look. So if we have a slow counter increment, let's say that we've got some wait milliseconds, and that'll be passed through on the action, right? And then we've got the slow counter over here. So what we want to be able to say is, I want to give the new state, but we have to wait some amount of time for it. So I can't return it to you right now, which this block of code is all synchronous right here. So I have to return something right now. So there is a value or a type in JavaScript that lets us wrap future values, and this is called a promise. And a promise is a wrapped future value that we can unwrap it when it's resolved. And so the code inside of here is we can tell it, hey, I'm ready to unwrap now. So what we'll do is we'll call the set timeout function that's just built into JavaScript environments. And set timeout takes a little function that's allowed to run when wait milliseconds has elapsed. This is the wait time. This is the action. So what we'll do is we'll resolve this with slow counter change. And the value is going to be, I think we can close this now. The value is going to be whatever slow counter was when we started. And then we're going to take its value plus slow counter value plus 1. Now, if you're a programmer that spends a lot of time thinking about concurrent code, like, yes, this does introduce race conditions. I mean, we can make it a little better by taking that value up here. you know, and then we can calculate whatever it is based on the time that we called the action. We're not worrying about race conditions and things right now. We're just kind of demonstrating the point. So we have that. That's basically how it will work for incrementing. Let's also do decrementing, which is basically the same idea. And we'll subtract. Now the important thing here though is that we're sending to this third action called slow counter change. And this is kind of a common pattern when we're dealing with asynchronous actions this way. So we'll have slow counter change. And recall we're sending the value through the action now. So let's take that back out. And we'll also want to update this slow counter state. Cool, so what we'll do then is we'll just return the state and update the slow counter and reset that to the original slow counter plus this new value. Okay, so let's design what a slow counter should look like. Slow counter, we're going to take in some props. And if you recall, we had, we want the value like we've always been taking. We also want this, the wait seconds in milliseconds, and we'll pass that through when we make our actions. And in this case, I actually just want to call this, like I want dispatch passed to me, and I'll just use it myself. So let's set up our increment handlers. We'll dispatch the slow counter update increment. And we're going to pass wait milliseconds through. We're going to do the same thing with decrement. And again, remember with these actions, we're just sending data along, right? They don't do anything. The framework does it for us, combining with that update function, that business logic. So that's what we'll do here is we're going to return a counter. This is just easier to read. Okay, we're going to return a counter, and the value is the same as before. The on increment is what the thing that we just wrote there. On decrement, the thing that we just wrote. This is what's bridging and hooking into the dispatch system here. Okay, so let's come back up to the app here, and we're going to add in a slow counter. The value should come from the state. And then we also want to give it dispatch. And let's say that this slow counter waits 1 second before triggering its updates. Okay, so let's review. We have our update, which is returning a promise instead of the new state. And this is going to be a promise for another action. And then that action will produce our new state once it's fired into the system. And there's different designs. We could make our our actions carry the asynchronous behavior, and in this case, we're just making the state, the update function, be the one that indicates when things are asynchronous. So we've got our updates in there. We've got our state in there. Let's look at our app and make sure it's wired in. Looks good enough. Okay. So let's come back over here and make sure everything's still working, so we can still add, we can still do things synchronously. Now let's see what happens when I try to do something asynchronously. Immediately the app freaks out. It tells me I cannot read value of undefined. Well, let's take a closer look and see what's going on. So let's come over to Streamux. This comes with another function called tap, and it lets me basically grab whatever's coming through the stream and do whatever I want with it without touching that value. So it's going to let me do things without affecting what's going through. So let's log out the state every time it gets changed. All right, so what I should be able to see is the state after the change, and there's counter 1 right there. So let's do that, and it blows up, but the last log that we got is all of my state is a promise now. See what's happening back over here in this update function is that if I go to this case, all of these other branches are returning data, but this is returning a promise. And we don't know how to render a promise, and we've replaced our entire app state with that promise. So we don't want it to do that. We want our update function just to deal with the asynchronous, like just deal with the state of the app. So what we want to be able to do is catch those promises as they're flowing through. So we can do that. Highland allows us to split streams. It gives us a function that will basically allow us to split the stream so that we're only dealing with synchronous and or asynchronous functions, and we have different logic for each. So our async functions, or events rather, will be our events. And just kind of like a fork in a river, we can fork the stream of events. And we're going to say that we only want the events that are promise events. So we'll put a little helper here. And what we're going to say is an event is a promise if it's an instance of. And this will return a Boolean if it is a true, right? So we're going to filter on that. And then what we want to be able to do is say, if it is a promise, then let's wrap them so that Highland can deal with them specifically. So like Highland can basically wrap a promise. We can see that from over here in the documentation. If we look at source, these are all the different things that we can do to pass to Highland. And it knows how to take a promise, and it will emit a value or a stream for a value when it resolves. So we don't necessarily want to have like a list of streams. We just want one stream. So that's where flat map comes in. So every promise that comes through will get wrapped in Highland, and it will just be a stream of those promises. And when they resolve, they become values. So that's basically all we need to do there. Now our synchronous events are going to be kind of the opposite events, and we're going to make a new fork just for these synchronous events, and we're going to reject all of them, all of the ones that are promises. And then from here, all of this code basically is the same. Whether they started as synchronous or not, they're all going to make their way to something in common, so we can merge our streams. Great. So that gives us the ability then to merge them all, and then we'll just continue doing our thing of just updating the state. I don't need that console log anymore. So assuming that we got everything right, this should let us basically send promises instead of data to our app. Let's just hope for no typos. Cannot read property value of undefined. We got a typo. Oh yeah, okay. This one's, I remember now. All right, so the reason that we have that is that we're still like getting these asynchronous ones through, and they are getting resolved, but you know, we're still sending them through the sync events. So here's what we want to do instead. We're going to take our state and our action, and rather than, you know, we were just passing it straight through because the function signature here is the same. But what we want is we want to inspect the result first. So if the result is a promise, we're going to handle it differently. We will write that back into the stream so that it goes into an async event. So we'll say dispatch of the result, and that puts it into the async stream. And then we're going to return the original state since we don't have anything to update right now. Otherwise, if it was a synchronous event, we'll update the result. So let's do that. That's going to keep the promises out of our stream. There we go. So what's happening now is that this is updating a second after I click it. So there is one problem with this though. Like, let's see what happens if I send in an update to increment this slow counter, and then I hit some of these other ones along the way. You'll notice that they didn't update right away. And that's because this asynchronous action is in the stream and it's blocking everything behind it while it's waiting to resolve. So to fix that, we can look at something called observe. And the documentation for that, we don't have to go into that too much, but observe here is basically like fork, but it's passive, and it will just hold and buffer onto data in the asynchronous stream. And there's really not strong guarantees. Like when we merge these together, there aren't really any strong guarantees about like what order things will come. And that's true of pretty much asynchronous code. Is you can do some extra work to sync things up, but you can also just design applications that are a bit more aware of those things. And that's why I was talking about those race conditions earlier. So anyway, that gives us a way to model asynchronicity in our programs. And we just did this with promises. That's not typically what you'll see. In Redux, we have this thing called thunks. Instead of, I could have returned a function that receives the dispatch option, and that lets us call dispatch more than once, so I could basically just do different actions this way. And I can call out a bunch of different times. The other thing we could do, or that you'll see out there, are something called sagas. And in this case, we return another object that the saga framework knows how to read, and it will do actions on your behalf. So like, I don't know, maybe there's like a call function, and it will say like, some HTTP library dot send or something like that, and you can give it arguments, and it will just know how to call those things for you. Or you can put things to put in new data. All of that. So those are two different approaches, but you get this idea. The thunk plugin is like, well, we want to model asynchronicity with functions, and Saga said we want to model asynchronicity with just data that our framework knows how to deal with. And in our case, we just did a different design. We were using promises. So the whole point there is that the concepts are the same, the approaches might be different. In our case, we just used something that's built into the browser, and it didn't take a ton of code to write. So let's make something that's a little bit more interesting than counting. Let's make a random quote generator. So in our case, our quote or state is just going to be an empty string. What we want to be able to say is, when I get a request for a new quote, I want to go call out to an API and get a quote. And I did manage to find an API that was free, didn't require any signups or anything like that. And it is kind of funny because it's just the Simpson, like the Simpsons from that show. It just returns random quotes from that. So let's say like we'll request a quote. And what this is going to do is we've got this URL here. What we're going to do is we're going to return a new promise. Resolve. And its job is to basically fetch. And we're going to use the browser's fetch API. So we're going to fetch at this address. Now I want to use the async await syntax, so here's the response, and I'll await for it. To use that though, I have to put async right here to mark this function as async. And then I'll get the data, and so I'll have to await the response's JSON data. And then from there, I already know ahead of time the shape of this API response. So what I want is the quote. It's a list of quotes objects, and each quote object is a quote property. So I just want the first. So I'm going to destructure it that way. And then what I want to do is I want to put this back into the system somehow, right? Now that I have this data asynchronously, I want to put it back into synchronous control code. So what I'll do is I will resolve this with a type of receive quote. And we'll pass the quote through the action. So what I'll do here is I'll wait for that receive quote. And I'm going to get the quote out of the action, and I'm just going to return the new state, and we're only replacing that quote field. So it's just waiting for things to be done, and then it will kind of handle updating our synchronous code again for us, updating the state. There's a lot of stuff that we didn't deal with here, like what if this failed or the API was down? What if I couldn't parse this JSON? Like there's other state we could model too. Like when we fire off this code, we're technically waiting, and if this takes a few seconds, we'd want to let the user know, hey, we're working on your code, but it's taken a bit. And like that's state that you could model, right? You could say like quote might actually be a string and its status could be like not started. And you could model stuff that way. In our case, we're just skipping all of that for purposes of demonstration. So let's come in down. The only other thing that's really left to do is to build a slow count or a quote component. So let's make a random quote component. And it's going to take the current quote. Let's also have it take dispatch so it can wire into our program. So let's return a div, and it has a block quote, and next to it, it also has a button. This block quote will have our quote, but if the quote is empty, then let's have a fall through, which would just say request a quote. Let's clean up this white space. And then here, we'll just make this say get quote. And then we'll put down here on click. Let's just have a quote handler. In this case, we're going to call dispatch, and we'll fire off. We'll just let the system know I'd like to request a quote. And that should be it if I did not put any typos in. So let's come back up to the app. And right in here, we'll put random quote. And we'll pass our quote from the state. And we'll put the dispatch method so it can hook in right here. And this is just a matter of style, like whether you pass dispatch into the component. You know, it could be a matter of style where I've seen in Redux apps where like the connect method or the connect function is just scattered everywhere, and like every component can talk and can connect into Redux. I've seen other styles where it's much more maybe disciplined and only the top level component or like these connector or container components are allowed to talk to Redux. And nowadays, you know, there's also with hooks from React, you know, you could also set up contexts and providers, and you can have like a use context hook, and you could wrap the components that you want to be able to see the dispatch function that way. So those are different approaches you can take. Again, we're just passing everything through. But you can imagine if random quote had a shared component inside of it that might need to dispatch, like we can only pass things so far down, you know? So anyway, hopefully everything's wired together. Okay, we have a empty request a quote. Let's hit this, and it updates, and it's pretty quick. So it's basically, you can see here, here's the API call that's happening. All of these still work. These are the synchronous buttons. Here's our synchronous slow counter, or asynchronous slow counter. And I can fire all of them without blocking anything else. And they're all just flowing through as streams going through our app. The thing that's making it work is that everything is going through Highland, and Highland's transforming everything to basically fit in the place where we want it to be. So that's my demonstration of Streamux. Redux is handling a lot more problems for you. It's giving you much more plugins. So for example, if we wanted to have to simulate like the logging plugin, we could come over to Streamux and then use that tap function, right? And just say like, you know, tap, this is going to be an action, console log the action. And this is going to be the state. And so we could theoretically just watch the state. This goes down here. We could watch the actions update as they flow through our app. And that could give us, you know, a little bit better sense. But I mean, Redux is so much nicer. You get better debugging. You get the time traveling stuff and integrations. A much bigger library. They've thought through a lot of other things. But this is basically where you'd be if just how to take a problem and abstract it and try to rebuild it yourself. And we're really stripped it down and simplified it to help you understand that, you know, your web apps are just responding to events and updating state. This gives you an approach for how to organize things. So if you want to learn more, I mean, I would really recommend learning a little bit about Elm, even if you never use it. My understanding is that Elm kind of helped inspire Redux. I would also spend some time looking at Redux. Also, you could spend some time looking at React hooks. But in general, what I want you to kind of come away with is web apps are just events and state and mutations on those things. and you've got a new way to kind of think about that. I would encourage you to also spend some more time looking at the React hooks, and specifically the use reducer hook. This is basically this pattern, but you can just switch on these same actions, and you've got state and dispatch coming out of use reducer. So like these are things that should seem familiar if you've never seen them before. We just use all of these terms, and in fact they've got the same counter example going on over here. So this is pretty common. It's going to be the same concepts which you all just should be exposed to now, and they're in your head as just abstract foundationals. And then when you see this library doing it in a different way, you'll have, it's the same idea but maybe a different expression. So hopefully that's helpful to you. Hopefully this was interesting. Thanks for watching, and that'll be it. That's done. Thanks.